Hi all, I'm Gayatri Padarla. This talk is about how you could make your inserts faster, and any PostgreSQL developer who is dealing with data uploads, this is the best talk for them to go through. I'm Gayatri Padarla. I work with Microsoft as a PostgreSQL performance expert. This talk is coming from the experience of multiple customers who have come to us asking why their inserts are slower. So, to improve performance, what all we did, what all suggestions we have provided them based on their workload is what is driving this talk. I'm a mom of two, happily married, and have a pet named Bruno, who is a chocolate Labrador. I love hiking and cooking. And I have been in Seattle for a long time, and I love hikes in Seattle. Currently, I'm living in Atlanta, and I'm exploring hikes over here. Thank you. Moving on to the talk. The talk is going to flow through these items, like how using unlock tables is going to help inserts, using copy command, how it's going to help, using batch inserts compared to single row commits, how that will faster your inserts, how disabling constraints, triggers, and indexes are going to help you with faster, improved performance of your inserts. Partitioning a table. Most of the times we think partitioning a table is going to help us with the selects, but now it also helps with the inserts. Coming to HA and RAID replica. What is the best time to enable your HA and create your RAID replica is what going to be presented here. And last but not the least, tuning server parameters. So, some of the key scenarios where we have seen customers coming to us asking for help is during bulk uploads, daily imports or incremental uploads, and transactional inserts from different applications. And this is what I'm going to cover all these three scenarios in all the proposals or suggestions which I'm going to present to you in this talk. Going ahead with unlock tables. So, unlock tables are a best approach when you go for one-time bulk uploads or incremental uploads where you are using some staging tables. So, because it's a staging table, you don't need the data to be stored there. So, in such cases, you could use unlock tables. Unlock tables are the tables which do not generate any WAL files, which means there is no delay or latency of generating the WAL file, putting it in the buffer, flushing it to the disk. All this overhead is removed. So below is the syntax to create an unlock table. Create unlock table name, and you can automatically convert a lock table to a unlock table and vice versa using the alter table command. Normally, I would suggest people, if it's not a staging table, but you want your inserts to be faster, I would suggest them to go ahead with an unlock table. And then when it is a quiet time for the server, then change it back to log table. Changing an unlock table to a lock table would take a lot of time. But because it's in the slow impact period of your server, that might really help you. There are some pros and cons leading to unlock tables. The pros, as we have already seen, that it's going to be very fast. This, I have run a performance test and I have seen that the inserts are 5 times faster and your copy command is going to be 10 times faster. Whereas the second pro is that it does not generate any WAL files, which means all the overhead on the server, which these WAL files causes by utilizing the buffers or by utilizing the IO resources, using which it flushes these WAL files to the disk, is all removed. However, the con here is if there is any crash happening, you're going to lose all the data in the unlock tables. And also, if you have HA or replication slot, or if you have a read replica, your data will not be reflected in those scenarios in your standbys or in any of your logical replication slots or in your read replica. So if you have any of these and you want the data to be replicated, you should convert the unlock table to a log table during your low performance time. Coming to using a copy command over insert, whether it's a bulk upload or an incremental upload, you can always choose to go to a copy command. Even the transactional, instead of using inserts from your application, you can use a copy command to push the data into the database, because it avoids all the SQL processes in between. The inserts uses the SQL process where it goes to the through the optimizer and stuff. That is avoided here, and it will import directly from the file system to the database table. So the transfer is pretty fast and more efficient. It reduces the stress on the database server, and the logging is also reduced because one copy command is going to generate one single log table, log file. And once that log file is generated and your copy command is completed, then the log entry is gone. And there is no network latency involved here. It might be risky using a copy command because it's just one single log. However, keeping the atomicity of the table, I feel this is the best approach, instead of not understanding with an insert how many inserts were completed or how many were not completed. So this is the best approach. Coming to batch inserts versus single commits. In most of your OLTP applications, you would end up seeing single inserts coming from the application. Suppose it's a medical or it's an insurance or any sort of domain, right? If you're adding one single customer by customer, then single commits happen. So in such cases, what you could do is you could do some micro batches, like batching up 10 records at a time, or batching records with all records submitted in 1 minute, and then submitting it to the database server improves your inserts performance 100 folds. So when it is a multi-row insert compared to a single row insert, your number of IO resources being used for a multi-row insert is very less compared to a multiple single row inserts which is happening. So inserting 100K records in one single transaction is very, very fast compared to performing 100K separate transactions with single row inserts. So that is going to be a big hindrance for the server performance, because each transaction is using up the CPU resources and the IO resources. And in this case, in single row inserts, the IO resources are going back and forth between the buffers and the disks and using up all the IO resources. Removing and disabling constraints, triggers, or indexes. When you're doing a one-time bulk data load, we suggest you to drop the indexes, drop the constraints, and drop the triggers associated with the tables to which your data is being loaded. So once the data is loaded, then you can recreate the indexes or constraints or triggers back. Specifically, when it comes to constraints, the unique constraints and the foreign key constraints are a big hindrance to the data loads. When it comes to incremental daily loads, we would say remove any unused indexes, because any insert you do, it's going to go and update all the indexes. The PG engine is going to go and update all the indexes available on that specific table. So be very careful on how many indexes you have in the table and how many columns are there in those indexes, because that will help you to judicially understand how you want to build your index. And based on that, automatically your insert performance is going to be very performant compared to the way if you have tens of indexes and if you are not using most of those indexes. So that's a big hindrance on the performance. So post all the data load is done, I would say create your indexes, create your constraints, create your triggers. And because these are maintenance activities, you could update some of your server parameters like maintenance work mem, max parallel workers, and max parallel maintenance workers based on your server config. Partitioning a table, how partitioning a table is going to help us when it comes to incremental daily loads. Partitioning, having a partition table and inserting the data into those partitions is going to be much faster. One, because it's targeting one single partition. Second, it's parallelizing the data flow and the data load to multiple different partitions. Third, if an auto vacuum is running, it's running only on the partitions for which a change has been made. Also, there is one more thing where if you have some data to be deleted from the partition, then that partition alone is being dropped. But the rest of the tasks for uploading the data into other partitions is still continuing. So instead of inserting a data into a 20 GB huge table, if you partition it into 10 different tables, then each table is only 2 GB, and activating and inserting the data in those partitions is much faster. Coming to HA and read replica, we suggest during migrations or one-time bulk uploads to enable HA after the upload is done, and then creating the read replicas and setting up the logical replication slot. HA is nothing but having a primary and a standby server. So whenever you enable the HA and then do a data load, what happens is whatever the data is loaded into primary, its WAL files are taken and implemented on the standby. And then once the primary gets an acknowledgement from the standby, then only the next set of transactions happen. So to avoid this all round trip, we suggest customers to enable HA later in the game after the data load is done. Creating read replicas, though it's an asynchronously replicated, but that replication again uses up some of the CPU resources and IO resources. And again, here also we suggest going ahead with doing the bulk upload first and then going ahead with creating the read replica. Coming to setting up the logical replication, it's always suggested to do it after one whole bulk upload or after the migration is complete. Moving forward to tuning the server parameters. Given all the above suggestions would have improved your server performance, inserts performance already a lot better. To further dig into it, we could tune some of the parameters like wall buffers, shared buffers, max wall size, auto vacuum, and checkpoint timeout. Let's start with wall buffers. What does the wall buffers do? Why do we need this parameter? What does it do? How is it going to impact our inserts performance? Let's talk about it. What does this do? So based on whatever, suppose you give 16 MB as a value for wall buffers. So here the PG writes the walls to the buffers until it reaches 16 MB, and then it starts flushing the wall files to the disks. So which means with 16 MB, if your transaction is huge like 20 MB, you end up frequently flushing the wall buffers to the disk, which means there is usage of IO resources. And as your buffers are filling up, the next transaction will not happen until the buffers are emptied. So that's again causing a delay. So to avoid all that, you could increase your wall buffers, and it would be based on your server config. It could go to a higher value of 128 MB. And if you set it lower, we know what the problems are going to be. So it's always recommended to set it to a higher value, whether it be one-time uploads or incremental uploads. Coming to shared buffers. Shared buffers are currently set at 25% of your RAM in Azure database for PostgreSQL Flexible Server. However, to improve your data upload and the incremental daily imports, you can change or increase your shared buffer values to 40% of your RAM, and you could go a bit further up on that, but beware that these are the same buffers which are used for other maintenance activities too. So please be very judicial in using the shared buffers or increasing the shared buffers parameter. Next, coming to max wall size. So max wall size and checkpoint timeout are very much interlinked. Both of them trigger the checkpointer. So the max wall size is determines how many wall files need to be filled in before the wall files are getting flushed to the disk. So normally the max wall size is set up based on your server config. So you could increase it up to 64 GB. However, I wouldn't suggest, if you have a very low RAM size, we wouldn't suggest you to go for that. Normally 2 to 4 terabytes storage size would use a 64 GB of max wall size. So during bulk uploads, based on how many wall files are getting generated, you could tweak this parameter to accommodate the number of wall files and then dump it to the disk. So this reduces, by increasing the max wall size, you're reducing the IO resources, and also you're avoiding the checkpointer to run frequently. Coming to auto vacuum. With all the above scenarios like bulk uploads and incremental loads, we suggest you to turn off the auto vacuum, load the data, run a manual vacuum, analyze on the tables which have been inserted with data, and then turn on the auto vacuum. This way, we are avoiding any hurdle or any utilization of CPU or IO during a bulk load happening. This will help us with conserving all the resources towards the data load rather than on the maintenance activity like auto vacuum. Now, tuning the checkpoint timeout. Suppose in a bulk upload, you know your bulk upload is going to take 1 hour time. To make sure your checkpointer is not running in between that 1 hour time, you can increase your checkpoint timeout to 1 hour. By default in Azure PostgreSQL, it's set to 10 minutes. And you could set it back to the default value once your one-time bulk upload is done, which means your checkpointer is not using up the CPU and IO resources when your data load is happening. Thank you.